Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll be discussing solutions to problems in the second paper of the 2013 JEE Physics Advanced Question Paper. I'll be working with code 0, but in any other codes the question will be the same, just the order will be shuffled, so you can figure that out for yourself. Particle of mass m attached to a spring of spring constant k, the other end is fixed horizontally with a speed u. Okay, so I'll not draw the spring just because it makes the image a little bit unclear. So the object is oscillating, this is x is equal to 0, right? It is moving and it would ordinarily move like this. However, a point here, it did not get to go to this point, right? It was here when the speed was u by 2. Right now it's u0. When the speed is u0 by 2, it hits the wall elastically. Now the wall is rigid, so obviously the velocities of separation has to be equal to approach, so it will come back with u0 by 2 and then it will move on its normal way and go back till this point because the kinetic energy is still the same. So that is what is going to happen. So option A, which says that the speed of the particle when it returns to equilibrium position is u0, that is true. It is going with u0. Basically what has happened is we removed this part and condensed it into a single instant. So the things relating to time will change, but if it's going with u0, here it's u0 by 2, the wall makes it u0 by 2 backwards. If it is u0 by 2 in this direction, after it comes here, then it's going to be u0 here. So it will be u0 in this condition as well. If this was a partially elastic collision, then this would not be true, but now this is true. B option says that the time at which the particle passes through equilibrium is pi root m by k. No, that is not true. That would be true if it went through the whole path and came back, but it only went through a portion of the path. So the time will actually be small, right? Smaller than that. So B is false. C, the time at which maximum compression occurs is 4 pi by 3. Maximum compression occurs when it is at the center, right? So now we'll have to calculate properly. So if the equation is x is equal to a sine omega t, because we can't directly say if 4 pi by 3 is wrong. If the equation is a sine omega t, then speed or v will be a omega cos omega t. When is it equal to a omega by 2, maximum speed is a omega. When omega t is equal to pi by 3 or t is equal to pi by 3. And since 2 pi by omega is the total time period, this is equal to t by 6. Right, 2 pi by omega is the total time period. So omega is equal to 2 pi by t. So t by 6. Now just let's write that. This is t by 6. Coming back is t by 6. This is t by 4, this is t by 4. If it were t by 4 and all 4, total time would be t, but it's smaller than that. So when does the maximum compression occur? It occurs at 2t by 6, that is at time t by 3. T by 3 is not 4 pi by 3 root m by k. T by 3 is, t is 2 pi by omega, so it is 2 pi by 3 omega, 2 pi by 3 root m by k, which is not 4 pi by 3 root m by k. So C is wrong. C false. D, the time at which it passes through the equilibrium position for the second time. That means it goes and comes back and goes and comes back. So the total time will be this time 2 pi by 3 root m by k plus half a time period, right? T by 4 plus t by 4. So that is plus pi root m by k. So 5 pi by 3 root m by k. So option D is true, which means the answer to this is A and D. Thank you.